welcome to Physics Solution Center. Today we want to look at electricity. I decided to break down this so that it can help every student. Are you one of those struggling with electricity? Well, I'm here to help you. I'm here to support you to ensure that you get it right. So we want to look at electricity by itself. I'll explain what is meant by quantized. I'll explain the use of Q equal to IT, and especially I equal to nAvq. This is something that is very difficult for some students to go about it. First, I will take you through the notes. After that, I will answer some past questions with you. Come with me as I take you to the notes aspects. First, let's start with this. It's important for you to note that electrons flow from negative to positive. That is how we have electric currents. And so what is electric current? Electric current is the rate of flow of electric charge. The rate of flow of electric charge. If we are saying that, it means that current equals to charge over time. Charge over time. Don't forget that. By the time we take time up, we have Q equal to IT. That is how we arrive at this. It is very important for you to know as well that the charge that we are talking about here is the number of electrons that flow through this circuit whenever we on our lights. That means NE is the same thing as charge. So number of electron charge. We can write it by saying that instead for us to just write Q equal to IT, we can write Q equal to NE. That N is number of electron charge. In other words, we can write that NE equal to IT. If we are asked to find the number of electron, we can say current times time divided by electron charge. And the value for electron charge is 1.6 times 10 raised to the power of minus 19. It's important for you to note that number of electron charge will always be integers. That means 1, 2, 3, 4, 5. We don't have anything that is decimal. This is where we say that electrons are quantized. Electrons are quantized. So whenever you see charge, it can be only multiple of 1.6 times 10 raised to the power of minus 19. You cannot have anything that is decimal. Kindly take note of that. Now, this is the aspect, current carrying conductor, that most students, most times they have issue. Why are they having issue? Because sometimes how it is being explained to them. This current carrying conductor, just have your mind, is like a wire. A wire. For a wire, you know that a conducting wire will have area and it has a length. The current that flows in a wire is due to charge carriers along the conductor. How does it flow? When we connect, there is what we call drift. One electrons will move. So as they are moving, that is how electricity is conducted. Each electron has its own speed. For us to find the speed of every one of them, we look at average speed. That is where we have what we call average drift speed. Take note of that. I want to quickly show you how to arrive at the equation. Most times they ask students to go about it. Now, for this area and length, you will agree with me that volume is equal to area times length. If that is the case, the number of electrons that can form on this is going to be the density of electron charge times area times length. Can you see? capital N equal to the number density, which is small letter n, times the area times length. So what does that mean? Look at the blue and the red that are flowing. The number density times the area and length will give us n. Remember we said that I equal to n e over t. If I substitute n with small letter, so I will have n a l e over t for current. However, I can change L and T to replace it with drift speed. What is speed? Speed is distance over time. In this situation, distance will be L and time is T. I can replace L over T with V. This is how we get I equal to N A V and Q. This Q, the small letter, is the same thing as this E, electron. From my explanation, I've been able to tell you that current is the rate of flow of charge. Current equal to Q over T. And I have told you that it is quantized. It means that it's only multiple of 1.6 times 10 raised to the power of minus 19 in integers. We don't have decimal. We have been able to see that Q equal to IT, and we have been able to derive I equal to ANVQ. Let's look at past question. This paper is 2023 May June paper 2-1. The question says a metal wire in a circuit has a length of 1.8 meter and a cross-sectional area of 1.5 times 10 to the power of minus 6 meters squared. The total number of free electrons charge carriers in the wire is 2.3 times 10 to the power of 23. There is a current in the wire so that a charge of 172 coulomb moves past a fixed point in the wire in a time of 2.5 minutes. Show that the number density of the free electrons in the wire is 8.5 times 10 to the power of 28 per meter cube. In this question, we are asked to find the number density small n. And we knew that capital N is NaL. So, as small n will be capital N, number of electrons divided by area and length. Let's pick the values. They gave us number as 2.3 times 10 raised to the power of 23 divided by the area is given as 1.5 times 10 raised to the power of minus 6 times the length is given as 1.8. Put that in your calculator and the answer will give you 8.5 times 10 raised to the power of 28 per meter cube. You can see how it looks simple because you know from the foundation. Let's get to the next question. Calculate the average drift speed of the free electrons. We know that I equal to ANVQ. We are asked to find V. That gives us I divided by ANQ. Let's go. We were not given current, so we have to find the current. What is current? Current equal to charge over time. This will give us, charge has been given to us as 172 divided by time, 2.5 minutes. We have to change it to second, 2.5 times 60. This will give us the current. We can move it to this point. We have our V equal to 172 over 2.5 times 60 times area, which is given to us as 1.5 times 10 raised to the power of minus 6 times n, 8.5 times 10 raised to the power of 28 and times Q 1.6 times 10 raised to the power of minus 19. Put that in your calculator. That gives us 5.62 times 10 raised to the power of minus 5 meter per second. Next question. A battery of EMF 9.6 and negligible internal resistance is connected in series with two fixed resistors and a thermistor as shown. The fixed resistors have resistance 3400 and 5800. The reading on the voltmeter in the circuit is 6. Calculate the current in the resistor of resistance 5800. Well, this has to do with connection of resistors. If you don't understand this question, check my video on resistance. You will get it. Since it is part of the previous one, let me just answer it at once. Because this is EMF 9.6 and this is connected here and it is 6 volts, we can find the voltage that will pass here. The question is calculate the current in resistance 580, which is this one. Current equal to V over R. Before we get the V to put, we will come to this point. 9.6 minus 6 will give us 3.6 volts. It is 3.6 volts we will use for this question. Current will give us 3.6 divided by 5800, and the answer will be 6.2 times 10 raised to the power of minus 4. Calculate the resistance of the thermistor. Looking at this is the thermistor and it is 6 volts. The current that we calculated, which is 6.2 times 10 raised to the power of minus 4, that is the current that will come here, enter this one, enter the thermistor. If we can get the voltage of this, we will know the voltage of thermistor to get the current. So let's do it together. Current in fixed resistor, that is the one of 3400, will be I, that is there. So V will be the same thing as 3400 times 6.2 times 10 raised to the power of minus 4. We get 2.1 volts. For thermistor, it means that 6 minus 2.1 will be the voltage, and that will give us 3.9 volts. Resistance of thermistor will be V over I. 3.9 divided by 6.2 times 10 raised to the power of minus 4. The answer is 6290. Question C. The energy stored in the battery is 2.6 times 10 raised to the power of 4. Assume that the EMF of the battery is constant. Determine the final energy stored in the battery after a charge of 330 has moved through it. Energy for a battery is the same thing as QV, because from what you learned, work done has to do with work done over charge. That is the potential difference. So energy will be QV. We have been given the energy as 2.6 times 10 raised to the power of 4 equal to the EMF is 9.6 times Q. Our Q will be 2.6 times 10 raised to the power of 4 over 9.6. Q equal to 2708 colon. Determine the final energy stored in the battery after charge of 330 has been moved. Final energy, you will first find the remaining charge by saying 2708 minus 330. That will give us 2378 energy equal to QV. 2378 times 9.6, 22828. This will be the answer. D. The environmental conditions change causing an increase in resistance of the thermistor. State whether there is a decrease, increase, or no change to the temperature of the thermistor, the current in the thermistor, the potential difference across the thermistor. Thermistor is a component whose resistance decreases with increase in temperature. Here, if resistance increases, it means that there is a decrease in temperature. The current, because the resistance is increasing, the current that will flow will decrease. Resistance is inversely proportional to the current flow. Potential difference across the thermistor, V equal to IR. When resistance increases, potential difference will increase. Here will be increase. Okay, so we have been able to answer the questions. This is 2023 May-June paper 22 question 6. The current in a filament lamp decreases. State and explain how the resistance of the lamp changes. When the current decreases, it means that there is an increase in the resistance, which opposes the flow of current. Mostly, there is also increase in temperature that causes an increase in resistance, which decreases the current flow. A cylindrical wire has length L and resistance R. The total number of free electrons charge carriers contained in the volume of the wire is N. Each free electron has charge E. The potential difference between the ends of the wire is V. Determine expressions in terms of sum of all of the symbols E, L, N, R, and V for the currents in the wire. Now, looking at these parameters given to us, we can say current equal to V over R, picking this and this. Let's look at the average speed. The average drift speed of the free electrons. Remember that we have I equal to A N V Q. Here is given to us as E. Looking at it, there are things we don't have as well. Don't forget, we also have N equal to N A L. We have capital N here. We have L, but we don't have A. We can change this to have N over L equal to A and N. With this, we can bring in to this place. So we replace I with IR equal to, we replace small letter N and A with N over L, and we now put V E. Let's make small v the subject of formula. That will give us potential difference, capital V and L, divided by capital N, E, and R. Can you see? This is just change of subject of formula. Once you can get this, you have gotten your 2 marks. The next question, the average time taken for a free electron to move along the full length of the wire. We know that drift speed is this length of the wire over the time it takes for it to flow. The average time will now be length of the wire divided by drift speed. We got this. You can see. So look at it. This is paper 2023, May June 20, paper 22, question 6. All right. Thank you for your time. Want you to subscribe, want you to share, want you to comment on it as I use this to help you to learn physics more. See you in our next video.